Hello pre-calculus class, this is Mr. An. We're going to do classwork on page 510, numbers 13 and 14. Please catch up on the reading and the video I assigned before watching this one. Alright, number 13, we are given three pieces of information, but the way they're laid out is it says a side, and an angle. Because the angle is not included between the two sides, this is going to be read exactly in that order, S, S, A. Now if we say that backward, that of course spells out ASS, a word I don't want you to say. And so we're in this weird, ambiguous SSA case that you read about. In an ambiguous case, SSA case, we would normally try to find H first and determine whether the other side across from the angle is too short, in which case there's no possible solution, is exactly the same thing as the height, in which case there's only one possible triangle we could draw, or the other side is larger than the height, and so we can either get this obtuse triangle or this acute triangle. But before we even go to finding the height, we must take note of this sentence here. Suppose we are given an acute angle alpha, so an angle that is between 0 degrees and 90 degrees. In our question, our angle is not acute, it is obtuse. Therefore, it is not an ambiguous SSA case. It's simply just an SSA case. So we're going to use the law of sines. On Monday, and also from the video, you know that for law of sines, it's sine alpha over A equals sine beta over B equals sine gamma over C. And you're just going to use proportion to solve everything out. Well, I'm going to use the second fraction and the third fraction because in the first fraction, I don't know this piece of information, I don't know this piece of information. So from here, I'm going to try to isolate sine gamma by multiplying 6.3 to both sides, and I get this expression here. From here, I want to isolate gamma, so I'm going to take it out of the sine expression by taking the sine inverse. So sine inverse is an expression we often used when we were trying to switch over the x and the y. So if of sine of x equaled y, sine inverse of y equaled x. So we get gamma by itself by using this expression. Plug that into your calculator and you get the angle 15.6. So as our second step, since we know two angles now, we can easily figure out the third one, the unknown alpha, since the three angles should add up to 180 degrees. So we do. Lastly, we're going to find out this information. Since we now know gamma, we already knew C, we knew beta, we knew B, we now know alpha. I'm going to use this proportion. From here, I'm going to cross multiply to get 15.6 sine 26.3 degrees equals alpha A times sine 138.1 degree, and from here I'm going to divide away sine 138.1 degree on both sides to get this expression. Plug that into the calculator and you get A and you're done. Now number 14 is a very similar question, but the reason why I need to go over number 14 is even though it's not an ambiguous SSA case, we can get no triangles possible sometimes. So just like with number 13, I'm given a side, and an angle, but because the angle is not included between the two sides, this is an SSA case. Just like with 13, however, this is not an ambiguous SSA case since the reading specifically told us that the given angle must be acute. Our angle here is not acute. It is greater than 90 degrees. So, uh, there are two ways to answer this question. In fact, let me go over the way you would have normally solved it and then go over the shorter method. So we're going to use the law of signs, plug the information in. I don't know beta, I don't know b, so I'm not even going to use this fraction and just use this proportion. Here I'm going to multiply 9.6 on both sides to get this. I want alpha by itself, so again, since sine of x equals y, sine inverse of y then equals x, I'm going to use sine inverse to make sure that I can isolate alpha. So plug that into your calculator and you get alpha equals roughly 66.2. At this point, you should already know that this is impossible, since in the second step, when we plug our known angles into this equation, we already see that the two angles that we have are already greater than 180 degrees, which is not possible, since that only leaves us with an option of having beta, which is negative. You cannot have a negative angle inside a triangle. So this is not possible. There's no solution to this. Now, as you can see here, I'd like you to be more familiar with this very quick method, since just one step. This is going back to geometry. In geometry, you learned that in a triangle, the largest angle is across the largest side. 128 is the largest angle of a triangle because you cannot have another angle greater than 128.6 and have all the angles added to 180 degrees. But 8.2 is not the largest side. 9.6 already is larger than that. So if gamma, which we're given, is greater than any other angle, so let's take alpha for example, then then C, this side here, must be also greater than A, this side here. And in our question, that is not the case. So we know automatically that is not possible. So no solution. All right?